Thank you very much. Yes, sadly, PHP Hampshire and PHP South Coast now defunct, but COVID has a lot to answer for. Yes, I don't need to introduce myself. That's already done. Thank you very much, Michael. So, picture this. You join a new team. Yeah. You're feeling great. You're excited to dig into some new awesome code. You grab yourself a cup of Yorkshire tea. It's only the best. I'll fight you on that one. You start settling into the work. Excellent. You've got your elephants at the ready. Let's get on with it. Wait. What is that? Something catches your attention. You think. What is this code doing? That doesn't seem right. How does that even work? Oh no, what's this? Who would do this? Oh, gosh. OMG, it gets worse. What is happening here? What in the fresh hell is that doing there? Why would you encapsulate this global state in this singleton? Why is this container available in a static object everywhere? No! Where did it all go wrong? What life choices led me to this inescapable hellfire pit of doom? What did I do to deserve this monstrosity spawned from the very bowels of existence, to be thrown into my brain mist and to decimate my very fabric of existence? Why am I screaming at a fluffy toy? How did I get here? They asked me whether I could reverse a binary sort tree in the interview. I thought I'd be working on complex algorithms. Instead, I am stuck with this terrible code. It's awful. It's legacy. I start with a question to you all. It's a rhetorical question. You don't need to answer. It's early in the morning. It's okay. What does legacy mean? Because there is an elephant in the room. Don't worry, it's my one terrible pun. It can mean old code, right? Code that uses outdated patterns. Obsolete code, but it's still being used. Difficult to maintain code. You know, we don't want to touch that. It will break everything. It uses old frameworks, libraries. It's fragile and potentially even untouchable because this one developer at one time changed their letter and it broke everything. So we don't touch that anymore. But nothing's using that code. Oh, yes, it is. Believe me. Systems that are also expensive to replace. There's lots of legacy hardware as well that runs these stuff that is decades old. But it can also mean working code, code that does its job, code that still provides value. I'm going to say value a lot in this talk. And it also includes code you've literally just written, right? So it's any code that is there. Right? To quote my friend and colleague Surgeon Vranets, code can be in two states, in production or almost useless. It's true. A common cause of so-called legacy code is fast iteration. Now at startups, certainly in my experience, this happens a lot. There's a reason. We want to build a product quickly, right? There's no time to waste. We need to get things done as quickly as possible. Use a RAD framework, which is fine. Use a snazzy tool to do some code generation. It's fine. Some library that takes away the pain of achieving a goal. The important thing about this, though, is that you are producing value by doing this. It's very important. But what you also need to remember is that sometimes you're going to be cutting corners to achieve this. And when you do that, you produce technical debt, okay? However, invariably, when if the product is successful, and it launches and you get past that initial crunch phase of actually delivering something, that is when you now have a big legacy code base. And you're like, oh, I wish this is done better. But it's okay, hold your horses. This is okay. It's okay to have legacy code. Another cause of legacy code is years of stability and iteration. Sometimes an application has been running for absolutely years. You know, I've been doing just PHP for about 21 years, I think, just PHP applications, and programming since before that. And so I've seen applications that have been running longer than I've been programming. You know, small modifications made here and there. You've added a new feature. Great, that's cool. The old features don't get touched. You know, they're still churning away, doing their thing. But you get the team turnover over time, right? People leave the team, people join the team, bring new ideas, eschew old ideas. So you get inconsistent styles introduced, and different implementation practices, inconsistent patterns applied in different ways, and you know, you end up with like, oh, we always used to do it like this, and then a new dev joins the team, and they say, why is it like this here, and over here it's completely different, but you're doing the same thing, but that's what you get. It just happens. And of course you get dead code, actually dead code that never gets executed, lying around. There's tools for that, right? And very commonly untested code as well. You know, that happens. If a project was made way before people like Chris Hart just started banging on about unit testing, and before Sebastian Bergman thought, oh, let's bring a unit testing tool to PHP. You know, testing wasn't even a consideration for half of us, probably. It wasn't for me. You know, I'm not afraid to admit that. I've learned since then. But important point is this kind of an application still produces value, and it is okay. It works, right? So what we need to remember is legacy, in quotes, is not inherently bad. It doesn't mean it's broken, and it doesn't mean you have to refactor that. We are, or a lot of people I've seen, me included in the past, have been obsessed with refactoring code. This talk is not just about refactoring code. It's about living with it. Hence the title of the talk, Living with It. And hopefully happily, right? We want to make up the place we work a nice place to work. And that includes the code you're working on. But we need to remember that sometimes it is better to leave it alone. If it ain't broke, don't fix it, right? Software that's been running for years or even decades is not inherently broken. Just because it uses some outdated pattern, like, oh, no one uses singletons anymore, and this was got it all over the place. It doesn't matter, right? Because it still works, right? Maybe it uses outdated methodologies or some weird deployment practice that no one ever uses anymore, FTP. Wait, no, we do use FTP. Yeah. So I'd like to propose that instead of calling it legacy code, we call it just existing code. That's what it is, right? So how do we tackle it? How do we live with it? There's two main topics I want to discuss, right? First up, sort of the general skills, right? These are non-technical, sort of soft skills, if you like, if you want to call it that. For me, as a self-taught programmer growing up, I was like, oh, this is great. I'm programming, child me, going back a few years. You know, oh, it's great. I'm programming on a computer. This is great. I'm making a mud or whatever I'm doing, right? I don't have to talk to humans or socialize or anything. This is great. How very wrong I was. Absolutely very wrong. So yeah, some of you may have started on that same journey. Others of you may be a lot more sociable and maybe find this bit easier. But certainly for me, this was a hard thing to learn, and I'm still learning a lot about, you know, communication and things like that. Let's talk about this. First of all, the communication with your business, right? For me, that's like my clients I work for. For you, that might be, you know, the business you work for if you're employed, or if you're also a freelancer, then your clients, you know. It's just people you work with, all right? These aren't necessarily technical people. These might be, your manager or, your account manager or whatever. The most important thing I've learned so far, that you need to set and manage expectations, right? Estimates are a very small part of that, but also incredibly important. And will often come back and bite you when they say, oh, you said it would take a month and it's now taken 4 months. Things will always change though, right? So managing those expectations early and often and not leaving your business or your client in the dark is very important. If you come up to them sooner and say, hey, I don't think we're going to get this done in a month, and here's why, and here's what we could do to improve that, they're going to like you a lot more than if you leave it 3 months and they're like, come on, you said this would be ready in a month, right? That's the subtle difference. So good communication with people like product owners, management, even executives if you're communicating at that level, yeah? And there's also your peer communication. This is the team you work with. They're probably going to be consisting more of technical folks, developers, tech folks, QA people, whoever's in your team. Other developers at your client or company as well, in other teams, in other departments sometimes. Because you're going to be collaborating and trying to agree a strategy. Certainly one of my clients have so many different development teams working on so many different projects. And like the CTO at the top of that company is like, I've got to try and make all these millions of teams do the same thing, or like at least roughly in the same direction that we want to use. It's hard job. So what I would say is always be open with your team at least, right? Discuss things openly, honestly, and be open with them. Don't like hold up whether it's things that you think about the architecture, things you think about like your team getting along, your friendships and relationships there, because that's important as well, right? We want to get along with the people we work with, because it's never pleasant not getting along with those people. Like, oh, I have to go to work and I don't like so-and-so because they always use strangler patterns for things, whatever. Many folks are also moving to remote working, right? I was working remotely before the pandemic, so I have some limited experience with this. We're moving a lot to using video calls. And so many times, especially in corporate environments, I see people not using their video cameras. And I would encourage them to turn your video camera on, right? Because this allows you to see facial expressions and be able to bounce off of that, right? It's very difficult to judge how a person is reacting to something you're saying if you're talking to a wall. It's essentially all it is, right? We do a lot of pairing as well. Hopefully some of you do. If you haven't paired with someone, try it out. It can be very draining for some people. I feel exhausted after a few hours of pairing, for sure. But it provides a lot of value because you get that dynamic that, at least you almost get that dynamic that you would have if you were sat in an office working together. And of course, there's our tech-related chats, like whether you're using Slack or IRC or Mattermost or MSN Messenger or whatever. Teams, I think they call it these days, don't they? Yeah. So, the most important part of doing this is just agreeing your strategy, right? Now, sometimes that strategy overarching may be set by someone else higher up, or someone with more leadership. But discussing strategy for what your pain points are in your team and potentially wider organization, and agree a direction on how to attack that. And if you do have like architects and CTOs and tech leads and so on in the team, make sure they're included, right? If one person says, oh, I think we should go this direction, another person says that we should go in another direction, and you have a good tech lead who will consider both those directions and say, on balance, I think this is the appropriate way to go. You have someone who's hopefully considered everyone's opinions and hopefully has selected the right course. Obviously, we don't always make the right decisions, right? Sometimes we make mistakes. But if you have someone to help facilitate those discussions, that will help a lot, rather than just making it democracy. Bit of both, And a tech lead might say, okay, well, let's put it to a vote, or some kind of approach like that. But it's important that we get buy-in from the whole team on things like tools, practices, and processes, and so on. So we need to define processes for certain things. That might be your expected typical workflow. I say typical because we can diverge from this stuff sometimes. How do we research specifications in this organization? How do we analyze the requirements? Maybe the number of requirements or specifications we have are severely lacking, in which case we might have to do a bit more digging and a bit more investigatory work. That's quite common, I've seen, actually. You know, people say, oh, I want this feature, and there's a whole load of assumptions based on their knowledge, you know, the person requesting this, their knowledge of the situation. So sometimes we've got to ask a lot of questions, right? So we try and explore those in more detail. Coming up with proposals for change, right? At one client, you know, we receive some specifications, sometimes they're quite vague, we ask a lot of questions, and we produce a proposal document, and we say, hey, this is what we are going to do. Then we have the team expectations for, you know, what we're going to be doing day to day. And that might be things like coding standards, linting tools, what testing strategy we're going to use, what static analysis we're going to use, and so on. And also pairing strategy as well. Some folks will say, okay, let's just dive in ad hoc as and when. Some people will like things scheduled in their calendar because then they can sort of manage their time effectively. So, you know, getting that and understanding that from your team is important. I, for example, am one that uses my calendar heavily. So if you want to talk to me, you know, beyond like a 5-minute quick call, it's best to schedule, you know, hour or something with me, and then we can go through and I can really focus on what you want, and we can make that a valuable time. Obviously not just organizing meetings for the sake of it, because we know that's the other end of that stick. Agreeing some kind of code and peer review strategy. You know, maybe that's, we want 2 or 3 people to approve all pull requests or whatever works for you. We'll come back to that. Some kind of CI, continuous integration strategy. What are we going to put in the CI pipeline? How is it going to work? What kind of things are we going to try and catch? Hint, everything. Documentation expectations as well. I'll come back to this in a minute. And also support and follow-up, and how do we actually support that once it's deployed and gone to production? You know, what happens if it breaks at midnight and whatever? How are we going to deal with that? How are we going to attack that? What if there's a disaster? How are we going to recover from that? And so on. Whole other areas of topics, which I'm not going to go into too much detail. But documentation. Things like these processes that you agree on should be documented. It should be written down. Quite often we'll have tribal knowledge built up in a team that never gets written down. The best time for observing this is when someone new joins the team, and then suddenly you have to explain the same things over and over again. And you're like, oh, maybe we should write this down so we can point the new person that's joining the team at this documentation. And I'm not saying just give them the docs and say, go and read that, because that's not very welcoming into a team, is it? But it's supporting that ingress journey into your team, you know? So you can still have calls about it and say, hey, this is how we do this. And this is where it says in the documentation, so you can read about it in your own time if you like, you know. Best place for this, I find, is in the code repository or code repositories in a folder called docs. And you stick a load of markdown in it or something like that. And that's because that's where we work a lot of the time. Not all of the time, but a lot of the time we're going to be working on the code base, as a developer at least. So it's going to remind us to update the docs when we're doing that code change. You can publish it. You know, you can use GitLab pages, GitHub pages, whatever you're using. There's common tools to make that sort of rendering happen. It makes it nice and easy to read sometimes. One of my clients heavily uses Confluence. Like everything they do is in Confluence. But their Confluence is behind a VPN, so I can never be bothered to connect to it. But it's okay, because we had a tool that synced our docs into their Confluence, and it just does it now. It's magic. We don't even have to think about putting our docs in their Confluence. But when you're writing these docs, you also have to consider your target audience. Sometimes these docs are intended for the client, for the business, and say, this is how the feature works, for example. This is what you've asked us to do, this is what we've delivered, this is how it integrates with other systems, and so on. Sometimes the docs are intended for your own team, like internal consumption. Say, oh, this is our development workflow, this is what we do day to day, we use such and such a tool because it's great and it has bells and whistles. All right? So take this into account when writing your documentation. Who are you targeting? Don't use necessarily technical terms when targeting the business people in the organization, because they might be like, well, I don't know what all this means, and they'll switch off. Diagrams help with that, make it simple, make the docs straightforward, and have just enough information that they need. But then maybe we have another documentation that goes into all the technical details that the development team need to know. So, we're going to look at technical skills and approaches as well. Like I said, for me, this is more of my comfort zone. Tools such as coding standards, static analysis, testing tools, and so on. So first up, reading code. This is a great tool. For me, this has been the most challenging thing to learn. It's so easy to write code. Honestly, it's easy to churn out a load of code. And you know exactly what it's doing when you write that code. Or maybe if you're pairing with someone, you both know what it's doing because you wrote it together. But if I write a load of code, and then someone else comes in the team and looks at it, what are they doing? They're reading the code, right? And now they have to understand it from a different perspective. They have to understand and follow what's going on. And in my opinion, reading the code is far more important than writing it. The more code you read, the better you get, and eventually you'll even get to a point where you notice, oh, I reckon that developer has written that bit of code, and you look at Git blame, haha, I was right or wrong, whatever. So yeah, refactoring and rewriting code is only really useful to the person writing that, because they will get a really great knowledge about that piece of code. They will become a subject matter expert, which is fine, but still, everyone else has to read it and understand it. So, I'm not talking about things like laying code out nicely and having tabs and spaces. That's coding standard stuff. We'll come back to that. I'm talking about actually understanding it. It takes a lot of mental energy to understand and model code and execute it, if you like, in your brain. So how do we get good at that? Well, how do we get good at Sudokus or anything like that? You practice. Yeah? You use it. You repeat that task a lot. You practice reading code. So you could practice by potentially reviewing code in open source projects. It's a great place to start. You can learn about an open source project, contribute, and so on. Start with a familiar language like PHP, but maybe even try other languages. Like maybe you've never written C or Rust or whatever. Try that. And see if you can follow what that code is doing in that small change set. The reason why I say do a merge request or pull request is because there's a small amount of code. So usually you only have to understand that context. Not always, of course. If you have pull requests, merge requests at your place of work, use them, review them. Yeah, that's obviously another great place to work, to start. Sorry. If you're uncertain about giving feedback, remember that you don't necessarily have to leave feedback. This is about you learning to read code. But try and make your own notes. And once you start writing things down, you're like, oh yeah, that I can turn into some valuable feedback for that person. Another very handy tool I find for understanding what code does is using a step debugger. Set up xdebug to work with the code that you're inspecting, and you can actually step through it line by line and figure out, oh, these variables change and things like that, right? I know some people, it's a, Marmite, love or hate sort of thing. Some people just don't like using step debuggers. Some people love using var_dump or DD or whatever you're using. And that's okay, but by using a step debugger, you're actually watching the execution of that code in real time. So even if it's just an experiment, see how it is. Run that code, see what it does, see what happens. It can help you reveal things about the code that you didn't know. For example, this variable is named wrong. It doesn't contain an integer, it contains a string, things like that. And another tip, especially for a code base without any tests, is to write what they call characterization tests, right? Write a test that says what that thing is doing, right? Take a method or function that's unclear, work out what it's doing, give it a set of input, expect a certain set of output, maybe it mutates some state in some way, that happens. But then that helps us understand, at least, right, that particular bit of code does this. If you give it that, it gives you that. Yeah? Another aspect of understanding is also understanding the business. What are the business's goals? What provides value to that company? And what makes it money? For many, many organizations, that is the goal, is to make money, whether it's to reinvest or do something nice for the world, hopefully. But the goal is to make money, and we use software to achieve that goal. So, does the software that we write achieve the goals of that business? Does it make the money? Does it make someone's life easier and quicker, and therefore save money? What does your product do if you have a product? And why does it do it? What are we trying to achieve with it? So trying to understand that high-level objective is also important for guiding our decisions as developers we make. A success factor that leads to happiness, I think, is a balance of developer experience and of business value. By developer experience, I mean the ease at which we can work as developers, reducing frustrations such as the code base is rubbish to work on, the CI is severely lacking, the processes that we've got are just not well defined, and we never know what we're doing from day to day. There's a load of project management overhead because they want us to submit a report about what we did at the end of every day. Those kind of frustrations. By eliminating those, you increase your productivity, right? And you increase your developer happiness experience, right? And by business value, I mean meeting the goals of the business, right? Whatever those goals may be, helping those your business make money, for example. Happy developers that deliver those business values means that the business values the developers. Yeah? It works both ways. So, should you refactor? We need to weigh up our options. What is the actual maintainability of the code? Does it just look rubbish, or is it actually really bad? Objectively bad, perhaps. How do you quantify that? I haven't got a simple answer for that. That's a one for you to think about. How easy can you change that code, though? And conversely, what's the cost of not changing that piece of code? Is it damaging the business in some way? Or take into account your developer experience. We hate working on that bit of code because it's always really risky, or something like that, right? Which leads me on to the next point, the risk of breaking something. How do we mitigate that? We write tests. Yeah, testing. If it's working, what could you break by refactoring that thing? And how much can we mitigate the risk of that change? Another factor to weigh up is what the value of that particular, maybe module or component, whatever you want to call it, what the value of that is to the business. If this is a really critical part of the business, do we want to change it? Changing that is a risk in and of itself. If you refactor and break something valuable to the business, taking payments, for example, if you're an e-commerce site, that's kind of important, right? If it ain't broke, don't fix it, right? Maybe we have some really rubbish payment integration that we really don't like working on, but we want to improve it. But if we improve it, we haven't covered it with tests very well, and it's going to break. So you need to weigh this up, case-by-case basis. I haven't got a silver bullet for you. I can't just say, oh yeah, do it or not. We need to try and leverage our experience and our peers' experience and the team and discuss this better. Sometimes refactoring is necessitated by change. we need to introduce this new feature, but to do so, we have to refactor this other component, because otherwise we can't plug it in or whatever, right? New features, also bug fixes, right? So there's potentially a different strategy for new features versus bug fixes. Maybe we've got a bug fix, and we really don't want to have to refactor that thing, so let's just find an alternative approach. Is that an acceptable trade-off? Refactoring is always a risk, right? So when we say, oh, let's refactor that, make it all cool and nice and happy and stuff, it's a risk. How much of that risk is what you need to weigh up? And don't just refactor because tech reasons. Oh, this new framework came out and it's really great. Let's start using it. JavaScript happens every day, right? You get a new framework. But you don't necessarily have to consume that new technology immediately, right? Don't just be like, oh, okay, let's switch to this. I'll give you a real-world example. Our team inherited a code base that was using Mockery extensively, and we saw some issues with it in this particular code base, and so we decided then that we're going to use just PHP unit from then on. But what we also decided is that the existing code we weren't going to change, because those tests that we're using Mockery still provided value. They still worked, they still tested the thing that they were testing. So what's the point in refactoring those to use just PHP unit instead? There wasn't really. So let's just leave them as they are. And just all the new ones will use PHP unit. And that's fine, because we've discussed that. We've said, yeah, it's probably not worth the time to refactor those because it's going to achieve the same thing, except we're just using a different mocking library. There's not much point, is there? So no, in our case, we did not refactor those tests. And to this day, they still work, hopefully. Let me just check. Yeah, we're obsessed with refactoring things, and not always for the right reasons, right? Refactoring just to use new tech X and Y and so on is not always the right choice. And potentially, I'd say sometimes a refactoring exercise could have been a reading code exercise, because maybe if we just read the code, understood it better, maybe added some comments to help explain and understand the flow, maybe that would have been a better option and much less impactful to the risk of the actual running of the business. So, let's say we've decided we do want to refactor part of our application. When we do this, we want to approach it to limit our scope of refactoring. We ask ourselves, okay, what is it exactly that we want to improve, and do the minimum amount needed to achieve that improvement? And then iterate on that. Do it again, and say, okay, we've improved that particular thing, we've deployed it, it's working, that's great. And let's iterate and do it again. So repeat that process, and we keep the change set as small as possible. Because what's that doing? It's minimizing the risk of change as much as possible, yeah? And the cost of change, and the larger it is, the more changes there are, the higher that risk. So let's make it small. As small as possible. And you might think, well, yeah, but we really want to make that improvement. Just take one step at a time. That's all I'm saying. Balance that developer experience, which is important, and your business value, which is also important. So make a plan. Say, okay, we're going to do this thing first, because that's the most annoying thing, and then we're going to do this thing because that's the second most annoying thing, and so on. And stick to that plan as best you can. And it doesn't always go to plan, right? Sometimes you're like, oh, actually, we've figured out that if we try and refactor this thing, it's definitely going to break this other thing, so we do need to refactor it. But that's okay, because that's necessitated change. So take your baby steps. Otherwise, if you try and refactor everything all at once, and I've seen projects do that, it will grind to a halt, and they'll be like, oh no. And then the business will be very angry at you, and be like, why did you do this? You've broken our important thing. So, tooling. Yeah, going back to sort of these general technical principles, practices, whatever you want to call them, tooling to automate checks is, in my experience, something that has almost always paid off. Great. Coding standards is an easy one, right? Some people will be like, it's not, what are you talking about? We need to decide between tabs and spaces. I'm here to tell you that it doesn't matter, because you pick a CS tool, such as PHP Code Sniffer, PHP CS Fixer, whatever you want to use. Agree it, be like, yes, let's use that tool, right? Pick a coding standard, PSR 12, or something more in-depth like Doctrine Coding Standard, whatever you want to do. Something that automatically fixes your code is important, right? Use something like that. Maybe not everyone will agree with the rules. Maybe someone will say, well, I can't read it if it goes beyond 120 characters because my brain will fall out and die. It's okay. As long as it looks consistent all the time, you get used to it. It's fine. You can always customize things to your team for less friction. Maybe we'll allow long lines or we'll disallow long lines or whatever you want to do, whatever works for your team. But set it, put it in your CI, make sure you're using a tool that fixes things for you so you don't have to think about it. And your CI will catch it if you do make a mistake. And if you want to be proactive, you run the tool to fix it. And it just does it automatically. You don't have to think about coding standards. Static analysis. To quote myself, probably one of the best things to happen to PHP since Composer is I honestly think that. I did tweet that. It's a gateway drug, at least it was for me, for understanding types and the benefits that they give. And you've got to take baby steps with this as well, right? Don't just enable static analysis and try and fix everything, because honestly, it will drain your soul. I've tried it. Instead, set it to strictest mode and use a baseline, right? Say, okay, we're going to accept all the existing issues as they were already there. We'll deal with them later. That's a great starting point. And from then on, any new code you write or any code you change, then you will have to fix those issues and make sure they are fixed when you submit it. One of the great things I did, or that really helped me at least, is setting a separate highlighting in my ID for just static analysis issues. Nice thing in PHP Storm, and obviously you can use whatever editor you want, but the nice thing about PHP Storm is that you can set it to ignore the baseline. So you can see all of the issues when you open a file. So it's nice and colorful. I actually use a light scheme now, but same thing applies, right? I look at the code and it's got lots of blue everywhere. I'm like, okay. So that's nice. We can pick and choose which issues we want to fix. So when we start fixing existing issues, you'll notice something. You fix an issue, and then a whole bunch of new issues appear. The chuckles were from people who already use static analysis, I can tell. For example, you define a type better and say, oh, that should be a string. You write string in. Oh, now these things that pass an integer in are all saying, oh, I'm passing an integer in when it's a string. So now you need to decide, should you fix those invalid usages? Are they real bugs? They might be. You could have found a bug. Or do you want to increase the baseline with that? Don't just do it blindly. Don't just be like, yeah, I'll just add all them in. It's fine. We'll deal with that later. Because that could be a real bug, right? So check. It takes a bit of time, but it's certainly a lot quicker than trying to actually fix all of the issues that exist. So guess what? Testing is a big part of handling existing code. Many times I've joined a team and there are no tests, nothing. Sometimes you'll join a team and some vague effort has been made. There are 3 tests, but they're not run in CI. I don't know, it's good. There's room for improvement though, right? But ultimately, what we need to remember when we're dealing with an existing code base is that good tests are better than bad tests. But still, bad tests are better than no tests at all, right? So, make a testing habit going forward. Every single change, make a merge request or pull request. Every change gets reviewed and every change should be tested, right? And your code reviewers need to say, if you've got no tests, we're not merging this, right? Obviously, there are exceptions. Oh, everything's on fire. Okay, maybe merge it and come back to it later. I'm going to talk about code reviews just for a minute. Your whole team should be able to review a merge request or pull request. Not just one person, the whole, not necessarily the whole team. But if you get one person, they can become a bit of a bottleneck. right? And don't necessarily get the same people reviewing your code every time, because you get the same sort of feedback. And you learn how to game that reviewer, if you like, yeah? Like, I know what they're going to say, so I'll just do it. But hey, that's actually kind of worked, because you're working better, right? One issue there is, though, that I've seen is less confident reviewers, right? They don't feel like they have the power to speak up and say, hey, we really shouldn't merge this. I don't think that's a good idea, right? And it's not experience, it's confidence, right? Maybe there's missing tests, and a new person's just joined the team, and they don't feel like they can speak up and say, hey, this code has no tests, right? So we need to empower those people. We need to discuss with your team. Anyone has the power to question things and say, hey, what about this in a review? But reviews and this kind of peer review is a discussion, right? It shouldn't be like a blocker or a big deal, right? And we need to help those less confident people to be able to discuss these things. Use things like when reviewing, instead of saying, don't do that, it's rubbish, say, have you considered and proposed something potentially better? Right? And that's just part of communication, right? It's respecting your peers. The reviewer's job is to ensure that the decisions that have been made in the change set have been made consciously, and that hopefully our changes don't result in technical debt. Doesn't always happen, right? Sometimes we consciously take on technical debt and say, yeah, I know it's not ideal, but we need to ship it for reasons X, Y, Z. And don't be afraid to make or remove policies. Like I said earlier, sort of like maybe you've got a minimum reviewers of 2 or something, and actually this developer is always out the office, so we can't get hold of them, so we can never get a review. It's fine. Change things, make it work for your team. That's important. There's usual policies, things that should usually happen. Like, we always want tests, right? Don't add changes without tests. Don't merge a red build in the CI pipeline. Don't merge something that, violated some PSR 12 rule or, with a load of static analysis issues. We want to strive for consistency there. There's always exceptions. So we need to be able to make the decisions to break those policies as a team and be aware of the impact, be aware of the trade-off that you're making, and try and offset the risk you can, if you can. Can you make a ticket to, let's talk about this later, because it's clearly getting us nowhere, and we'll come back and fix it later, for example. And some policies are flexible. Shall we increase the static analysis baseline? Sometimes it's okay, as I've said. Documenting stuff better. And when I'm reviewing stuff, or when I see code reviews happen, I think there are a few possible outcomes for everything. All discussions, right? All threads that you have. Should be either a change to the change set, a discussion where we decided, oh yes, there is sound reasoning why this was done the way it was. That's great, we'll close the discussion. Or a ticket or issue to defer it and discuss that issue later. Now let's talk about that later in the next sprint or whatever, yeah? Because it may be not important now, but it's something important. If someone takes the time to review your code and create discussions, and I've seen this a few times, it's incredibly frustrating for the reviewer if the comments are then just ignored. Close all the threads, merge it, job done. Oh. That person's taking the time to try and understand what you're doing, and maybe they had some questions, and you just ignored it. It's like pairing, but not listening to the person you're pairing with. Yeah? If someone's code is being reviewed, it's frustrating as well to have your code torn apart and end up with 3,000 comments and threads. Oh, it's going to take ages. Yeah? But it's important to remember that reviews are not personal. The reviewer, at least they shouldn't be, right? The reviewer is not criticizing you as a person or your code, really. They are just looking out for the best interests of the team, if they're doing it with goodwill, of course, right? Be like Kieran, right? Kieran worked on a new change. He actually sort of discussed with me about it, and I was like, yeah, that seems like a reasonable change. He worked on the change. It was reviewed by a team member. Then the team member says, I recommend we don't merge this. And Kieran tried something, it worked, but it had other drawbacks. There was a good reason that we shouldn't have merged that code. And Kieran says, never be afraid to delete your own code, right? Usually it's not quite as drastic as this, but this was demonstrated this relevant point. Marco wasn't criticizing Kieran as a developer, right? I saw the review, and I know people have varying experiences with Marco, but I thought it was a very considered review. He put across many pros and cons of the change. He empathized with the reason that Kieran wanted to propose that change. It was like a quality of life developer experience thing. And there was an amicable and respectful and professional discussion that ensued, and in the end, Kieran agreed, yeah, let's go and try something else. So he did, and then the follow-up was great, right? But it's about respect of your peers, right? That's absolutely important. And it's just like any communication, right? So one other approach to no tests is work out where the business value is and write a single happy path to ensure that that feature works. For example, not saying this is the only way, but just for example, if you're writing an API or maybe a web UI, you can black box test it. So which is where you run the application, stand it up in some kind of test environment, write a test that calls whatever API endpoints or makes UI interactions that you need to be done, and use that flow. And you've got one test, right? You could use Behat to do that. It's not strictly behavioral-driven development, but it does solve a problem. You're using a tool that's maybe not perfect for that, but you're solving a problem because you had no tests, and now you have one test. Nice. That's a good start. Characterize features that exist as well, that provide business value in this way. The point is not necessarily to write beautiful tests, worded perfectly in beautiful behavioral language that would be, make the BDD experts proud. I work with Kieran, and he's constantly criticizing my behavioral tests, but it's fine. I know why he's saying it. The point is not to form a beautiful test triangle, a big unit test suite, medium integration test suite, and a few API test suite. The point is to make sure that you don't break critical functionality, the bits that deliver those business values. So if you do refactor, you don't cause regressions. It's not a forever solution as well, right? It's important to remember that. Because maybe that particular approach, you end up with difficult to maintain tests, right? But you've made that trade-off. You said, okay, but we've got a test now, that's fine. It may be a really brittle test, but it's okay. We'll come back, we'll improve it, right? You've characterized what the application is doing and what's important to the business. Once you have those critical paths, then you develop on that. You start building on your test pyramid, right? You fix a bug, you make a judgment call. So do we want a unit test for that? Do we want an integration test or whatever, behavioral test? It depends on what broke, how it broke. Maybe it was something to do with character encoding. So maybe a unit test is fine there, yeah? The key is to stop that issue from happening again, that bug from regressing. If you're writing a new feature, obviously we want to make sure we've got great unit test coverage, and that's great. Maybe some integration tests if necessary. Define the behavior and test it at the code level rather than using API or UI interactions. And you can do this now because your new code is well designed. Changing existing features, sometimes it's necessary to characterize what's already there. If it has no tests already, and that's okay. Remember any test is better than no tests. But limit the scope of these characterization tests, right? They are valuable, they produce value, but are limited in some ways. They tell you when things change. They don't necessarily tell you behavior has changed, it tells you something has changed. If a test fails, we need to analyze the failure. Do we fix the test, and the change is okay? Or do we fix the code, the change wasn't okay? And then delete the test. It's controversial, isn't it? Deleting tests. It's okay. If we keep fixing the same test over and over again, because we keep making changes and it keeps breaking that test, consider whether that test is actually valuable or it's just a pain. If you have a well-tested component, good behavioral tests, integration tests, and so on, that's okay. Maybe it's time to delete those tests we started off with. This is down the line, right? Not always, though. One project I work on, the characterization tests still produce value. They still and some of them have evolved into much better behavioral tests, written nicely and all that, and that's good, right? We always look at ways to improve it. But the point is to get to a point of safety. So we've got something that says, yes, your application is working. One thing that I always assumed people thought, but maybe it doesn't, right? We need to make sure our tests are always run in continuous integration, right? Because there's no point in writing a load of tests and not running them, right? These tests should be run so you get your red and green feedback. You need to get to a point where all changes must be green before merging. If your trunk branch, whether main or develop, whatever you call it, is failing, fix it. It needs to be green, right? Because you need to have a working application to make changes to start off with. So if you're starting off from a point where everything is red because the CI pipeline was rotting, break it down. Turn everything off, right? And turn your tests back on one by one and fix them as you go along, right? There's no point in having red pipelines all the time. It produces no value. You may as well not have them, I think. And what do we add into CI? Well, everything, all the things. CS checks, test, static analysis, open API description, linting, documentation generation, and maybe even test the examples in your documentation. Code coverage generation, ORM, migration checks, things like that, security checks. So many things you can put in a CI pipeline, and the more stuff you put in your CI pipeline, the more confidence you have. And it's quicker running this stuff in a computer than it is you running that. So use it, right? It's cheaper to pay that computer to do its thing than it is to pay us to do that. So, to summarize, legacy is not bad, it's just existing code, right? If it's in production, it's probably producing value somewhere. And how do we tackle those existing code bases? Well, remember that we don't need to refactor. We need to communicate with our peers in our business, produce lots of documentation, make that easy to document so you don't forget to do it and it gets out of date. Learn to really read code and understand it. Determine what produces value for your business and weigh up those developer experience versus business value decisions. Use tools heavily to improve code quality, because they will help. Characterize your critical functionality with tests if you have none. Yeah? Build up your test pyramid if you've got some. And automate them all. Thank you very much. Are there any questions?
Thank you, Kieran. Wasn't that great? I really enjoyed it.
Thank you.
Thank you, James. Has anybody any questions? No? Ah.
Hello. Yeah. Where and how do you set your error level for working with legacy code?
With what, in relation to what exactly? What, static analysis tools?
Well, anything really. Say you're working on some legacy code that relies on PHP's ability to handle undefined variables.
Well, something like that, tests are going to become invaluable, right? Your unit test suite are going to test something like that. We have situations where we'll have some quirks that we rely on. Certainly, things like internationalization are not necessarily easy to test with. So, for example, I can't remember the exact issue, but there was something where there was a rounding issue with a particular currency, where the internationalization library was rounding it to the nearest 5, I can't remember which currency it was, but it shouldn't have been. All right, so we ended up with everything was coming out at 0.05 cents or whatever the denomination was out. So we wrote a test that we can't actually run in CI because the CI was always working. We could only run that test if we specifically set it up in a certain way that wasn't necessarily reproducible with like any Docker images that exist these days. It was a really specific test. But that kind of a test will allow you to encapsulate almost documentation about that particular issue and say, hey, at some point this currency in the wrong version of the library that we can't actually compile anymore because the source code disappeared or whatever, that will make sure that doesn't fail. And so we can run that test in a particular environment if we need to and verify that we're using the right version of the library. And of course, the solution actually is to install the right version of the library on the server. But we couldn't find the wrong version of the library in order to reproduce that test reliably in CI. We've captured it, but that was a difficult situation because we're like, well, we've got a test that doesn't run in the CI. So there's always exceptions, right? I say, oh, make sure it always runs in CI, but we couldn't run that one. But as for setting your error level, it's whatever you're comfortable with. And I would say go as strong as you can. Something like SAM or PHP stan, I would set to the highest level and accept a baseline, for example. And we know that changes from then on are going to be good, and then we can refactor slowly as and when necessary with your existing stuff. Does that answer your question? Kind of. We'll talk more after, if you like. That's fine.
I believe James will be around. The thing is, we are coming now to a 50-minute room changeover. So give another applause to James.
Thank you very much, folks.
Thank you.